Hello, this is Dr. Mode, and welcome to this chemistry lesson on heat. This comes from chapter 15, section 2. We're going to do the first part of this section. In the picture here, what we have is a bomb calorimeter. Our scripture from today comes from Revelation chapter 21, verses 6 to 8. And he said to me, "It is done. I am the Alpha and the Omega, the beginning and the end. I will give of the fountain of water of life freely to him who thirsts. He who overcomes shall inherit all things, and I will be his God, and he shall be my son. But the cowardly, unbelieving, abominable, murderers, sexually immoral, sorcerers, idolaters, and all liars shall have their part in the lake which burns with fire and brimstone, which is the second death." The essential question of the day is, how is a calorimeter used to measure energy that is absorbed or released? So, how do we know how many calories are in that potato chip? Well, one way that we can determine how much energy is in something is we can use calorimetry. So a calorimeter is an insulated instrument used to determine how much heat is absorbed or released during a chemical or physical process. So the specific heat of an unknown material can be determined using a calorimeter. The first slide had a picture of a bomb calorimeter. And the reason that it's called a bomb calorimeter is because the pressure inside remains inside. So the pressure can really increase or decrease inside there. But what we can do is, if we want to keep the pressure constant, we don't need such a fancy piece of equipment. We can just use styrofoam cups because they're really good insulators, and use that as a calorimeter. So that's what we see here in the picture, and you see that it has a thermometer going in the side. So they can be used to determine the specific heat of an unknown material. So here's an example problem where we're going to determine the specific heat of an unknown metal. So a piece of metal with a mass of 4.68 grams absorbs 256 joules of heat when its temperature increases by 182 degrees Celsius. What is the specific heat of the metal? Which metal could it be? So let's record the values that we see in the problem. So the Q we can see is 256 joules. The mass is 4.68 grams. And the delta T is 182 degrees Celsius. Well, we can just use our equation, Q equals mc delta T, and solve this equation for C. So C equals Q divided by m times delta T. So if we plug in these three values, we find that the C corresponds to 0.301 joules per gram degree Celsius. Now this number by itself is not that interesting or useful, but what we know is that different materials have different specific heats. So if we look up in our book or in a table where there are different specific heats listed for different materials, we can see that this value corresponds to strontium.